deploying a model. Wait, does anybody else have any questions? Thomas, could you let me know if there's anybody typing anything?
Yeah, there's nothing up there now, so everybody's good.
Okay, let me show you something real fast. And I'm going to post this later on. So today is August, right? So I did this earlier today. Okay. So this is what I did here is I'm just simply taking our wine data set right here. And what I did with it was I first took our target value, which was how many bottles of wine did the guy sell. So here's what I'm doing. I'll explain it to you real quick. I did a proc univariate here, and you can see that most, there's a big spike here. This is a zero inflated Poisson model. And then I have a couple of people bought like 1 case of wine and 2 and 3 and 4 and then 5 and then 6 and then 7 and then 8. So I've got, this is how many cases of wine the people bought. So what I did was I simply said, I'm going to approach this a couple of different ways. One is I have target, and target is just a raw number of how many bottles of wine did I buy. Okay. Then I'm going to create 2 new variables in case I want to do a hurdle model. This one here, target flag, what's that guy? What this guy is doing is he's just simply saying, did the guy buy more than 1 bottle of wine? Did he buy any wine at all? If he bought 5 bottles, then it's a 1. If he bought 1 bottle, it's a 1. It's just going to be a flag, or 1 or a 0. If he bought no wine, it's a 0. If he bought anything more, did he buy something? Now, remember last unit, we were doing logistic models. So this is going to be a flag of 1 or 0. Did the guy buy some wine? Then what I'm going to do is I'm going to subtract 1 from it. And I'm simply going to say, did the person, if he did buy some wine, how many bottles of wine did he buy? And the reason why I am subtracting 1 from this guy is because I'm going to do a Poisson model, and Poisson distribution can go from 0 to infinity. Well, if I'm only going to look at people who bought 1 bottle of wine to infinity, that's not really Poisson. It doesn't really matter, but I'm just trying to be a purist about this. So I'm going to create, so if I had wine that goes from 1 to infinity, I'm going to subtract 1, and now my distribution is 0 to infinity. Then I'm going to build a model and add 1 right back to it. Okay, so let's walk down this path. Here is where I'm doing some stuff like fixing some missing values. And if you want to know how I'm doing this and why, I'll tell you what. You can watch the video from, I think, last quarter or the quarter before. This is the stuff I did, and I really focus on fixing missing values. I don't really want to, unless somebody really wants me to go into it, I don't want to go into that right now. But I'm happy to if you really, if there's somebody who doesn't get something. I'd like to move on. Does anybody have a question about what I'm doing with this? I mean, has anybody not watched the videos from last quarter? And
nobody seems to be typing anything, so.
Okay. The winter quarter, okay, this is from the winter quarter. Please don't feel bashful about asking. I'm not going to yell at you if you haven't watched those, but I highly recommend you do that because I really crawled into weeds about how to fix the missing values. That's where I did it, and it took me like all night, and I would really rather not do that right now, but again, I'm happy to do that. But here I fixed all the missing values, and now here is where I start building the models. I come down here and I did a proc regression. Okay, now for the proc regression, I'm just going to use the raw target. This is how many bottles of wine did the guy buy? 0, 1, 2, 3. I'm just using the raw value. Now, in theory, you can't use regression model on this data because this data is not violates all of the assumptions of linear regression. So in theory, if you do this, you're going to get a bad answer. But if you guys remember from Predict 410, there's a guy named John Tukey, and he wrote a paper, and he was the guy who created exploratory data analysis, and he says, hey, yeah, if you violate all of the assumptions of OLS regression, and you still throw this data in there into a linear regression, you still get a pretty darn good answer because it's pretty bulletproof. This is bulletproof stuff. So this is the point that he's making. So what I wanted you to do is build a regression model and see. The neat thing about linear regression is it's really easy to implement and really easy to use, and it's easy to understand. Everybody gets it. And I'm just telling you, hey, throw your Poisson data into this guy and see what comes out. You might get something that's not quite as good as Poisson, but it's pretty darn close, and it's really easy to get. So what I'm recommending, and of course, if you don't want to do this because it violates theory, I get it. Some people don't like this. There's other instructors in this program who would think that it's heresy what I'm telling you, but I'm giving you some experience. It doesn't hurt you to try it, and you might get a good model. So I'm just going to build a regression model right here.
Hey, Tom, real quick, we got a request to repost the Tukey paper, but I would think that you can Google search that pretty easily, right?
I would be happy to. So I will post that. It's actually not the Tukey paper as much as it's a chapter from Ratner's book. And he talks about the Tukey paper. I will post that, though. So it's chapter 1 of the Ratner book. I will make sure I post that. Here, let me better write that because I'm going to forget. The moment this phone hangs up, I'm going to forget. So, heck, I know what I'm going to do. New. Post Ratner paper. There we go. Okay, so if you look at the coefficients real fast, these were the coefficients that came out of there. Okay, so now if I go down a little bit, this is the proc regression, and incidentally, I'm output the values here, and then I'm going to calculate the values. So I come down here, and when I'm doing my score code, this is what the regression did. So for example, you can see that my intercept was this guy, and if you actually look at the intercept, 3.06747, and 3.06747, the imputed stars, 0.81011, 0.81011. So you could see these guys are all these guys here. I mean, is there anybody, Thomas, do you see that does this make sense to you that I'm just typing in that formula? Getting some silence here. Did I lose everybody? Is there anybody on the phone?
Sorry, I had myself on mute.
Oh.
Yeah, I'm good. We did have a couple things in the chat box from Justin Floyd.
Okay.
Since ProcGenMod does not have an automated variable selection, would it be wise or unwise to use the same variables from, say, a ProcReg backward selection for the Poisson model?
It can't hurt. Okay, what have I been teaching you guys all quarter? If it makes sense and you get a good answer, you can do it. So the short answer, go ahead.
I was wondering the same thing along similar lines about whether the variance inflation factors from a ProcReg on Poisson data are meaningful.
Probably not so meaningful, but again, a lot of demons keep me awake at night, but multicollinearity is not one of them. The only time multicollinearity starts giving me problems is when I look and I get like sign values that don't make sense. Like I can see like multicollinearity between traffic tickets and drunk driving. Usually they're highly correlated. So if they're so highly correlated, sometimes you get a situation where the guy who drives drunk has a negative sign, which means the more he drives drunk, the safer he becomes. That's the kind of thing that does keep me awake at night, is when my answers don't make sense. But I don't really sweat it other than that. But what I would do is, because GenMod, later versions of SAS, GenMod does have a select, but it doesn't in the one you have right now. But before, in the olden days, back when people would walk to school and use telephones that plugged into the wall and had a dial on it, back in those days, people didn't have any variable selecting tools. So what they would do is exactly what you just asked. They would use proc regression or proc logistic, run a stepwise or a forward or a backwards, use a nice decision tree, try a couple of different things, and then throw those things into a GenMod. There's nothing wrong with doing that. Again, a purist would probably tell you that's crazy, but you know what? If it makes sense, and I think that makes sense, if something is predictive in OLS regression, it's probably a little bit predictive in GenMod. I mean, there's probably some correlation there. So it makes sense, and if it's giving you good answers, go with it. And you can even, and it doesn't even have to be completely automated. You can build a stepwise selection, take those variables and put it into GenMod and say, I just don't like this variable. Take it out. There's nothing, this is what they're paying you to do, is to use your expert knowledge, okay? Have confidence in your ability. So anyways, I built this guy with this guy here is just this guy right here. Now, here is proc GenMod with negative binomial. Now, incidentally, some of you students, depending on the version of SAS you have, later on we have zip models, and there's also ZINB, zero inflated negative binomial. Some versions of SAS, some of the older versions, don't have zero inflated negative binomial options. If you can't do it, you can't do it. But I'm just saying you might get an error depending on what version of SAS you're using, because ZINB is new. So I'm just letting you know that right now. Don't lose too much sleep over that. Okay, so anyways, here, I'm going to do a GenMod right here. I'm going to run that guy. And you can see I've got like 1.2383. And if I come down here and look at the score code I write for it, here it is. But when I'm done, I have to exponentiate that guy. So I do this, and then I have to take it to the e power. So whoever asked that question, Thomas, were you the one who was asking that question? I know a couple of people asked it. Does this part make sense? We'll keep moving on, but I want to make sure, do you get what to do for the GenMod?
I do, and I don't see any comments in the chat.
Okay. So you could probably deploy that guy no problem. You just simply do, here's a GenMod right there. And it would be the same for GenMod, for negative binomial and zip. It's the same one. You just take this guy here, you get the coefficients, you plug them into a formula, and then you do exponent of that. And then you let nature take its course. Easy as falling in love. Okay, so we got that guy right there. The next one let's do is we now do a hurdle model. And I did 2 hurdle models here. The first thing is, remember we built that flag. We said the flag. Now, up till now, we just had the target. This is just the raw number that we had. Now we're going to do a hurdle model. What's the hurdle model? First thing we do is we're going to do target flag. And what are we doing there? We're simply, remember that flag was 0 or 1. Did we sell any wine? And I thought, what the heck, I'm going to do it for the stars. How many stars did the wine reviewer give it, label appeal or whatever. So This guy here is going to give me a probability that the person sold some wine. Okay, it's going to give me 30% or 80% or whatever. Then I'm going to take the target amount. This was the number, the amount of wine I had. I throw away the zeros, so I don't have any zeros. Remember, I'm only going to do this with if you actually sold some wine, how much wine did you sell? And what I simply did here was I built a proc gen mod, and I decided to use negative binomial here. I could have just as easily done a zip model, or not a zip, a Poisson model, POI. It could have been either one, didn't matter. So I built that one. Now the other one I did was I also built the second one, and I wanted to show you how to do a class. So in other words, the stars, when the wine reviewer gave it 1 star, 2 stars, 3 stars, 4 stars, I'm using it as a number here, but you could also use it as a class where it's possible that 1 stars and 2 stars and 3s is not linear. So I just thought I would show you how to do that. So when I do this guy, let me run these people. So here's the proc logistic. Let me run that guy first. And you can see these are the coefficients.
Hey, Don, the question I had there on the proc logistic is, are we doing the probabilities that someone will buy wine, or is it a probability of 0 of not buying wine?
Well, this is, oh, I see. In this case, if you put the if you do reference equals 0, that means he's going to give you the probability that somebody is 1, which means what's the probability that he will buy wine? Does that make sense? Does that answer your question? No,
yeah,
it
makes sense. I guess I was under the impression that when we did the logistic part of this, that we wanted to focus on the probability of being 0, of not buying any wine, and maybe I was wrong with that assumption.
No, we want to do the probability that the guy is buying wine. Okay? Now, there's a reason for that, and I'll show you why in a minute. So right now we're starting off with just what's the probability that the guy's going to buy wine. Now, when I did that, here are my answers right here, my coefficients. And if you come down here, this is something you should have done before in the last section, okay, Unit 2. So I do probability of, here's the probability that the guy buys wine. And then I capped it off because I don't want these numbers getting too big. This is just a good technique. So if it's bigger than 1,000, I'm saying you can't get bigger than 1,000. You can't get smaller than minus 1,000. Then I simply convert it into a probability because this is the log odds. So you convert it over. This is the way you convert this into a probability. So now I have the probability you're going to buy some wine. Then the next thing I'm going to do is I'm coming up here and I'm saying, now, proc gen mod, and I'm going to build, if you did buy some wine, how much wine are you going to buy? So I'm building a gen mod here. I'm doing 2 different ones, gen mod 1 and gen mod 2. And if I do this, here's this guy, and you can see stars is 0.1253 and 1.1, whatever. If you look down here, here's my hurdle mod, or this is how much, if the guy did buy wine, this is the formula. And then I do exponent here. Okay? And if I decide to do it the other way, where this guy's a class, I'm just showing you 2 different ways to do this. I'm telling him that this guy's a class, and if we do this, we get, the stars of, if there's 2 stars, then you multiply it by this. If it's 3 stars, it's this. If it's 4 stars. So they buy more wine if there's more stars. Okay. So this is how I do that guy. So if the imputed stars is equal to 2, then I multiply it by this. If the imputed stars is equal to 3, that's how I do it. And then I do the exponent. Then I simply take this guy, add 1, because remember we subtracted 1, we got to add him back. And then we take this guy, we're going to add him 1 back, and then we multiply them both by this probability value. So if there is a 1% chance that I'm going to buy 1,000 bottles of wine, then if I have 100 people walk in the door and I say they each have 1% chance of buying wine, one guy's going to buy wine and he's going to buy 1,000 bottles. Okay, the expected value is 1% of 1,000, which is 10. Okay, so that's an expected value. I expect a guy that looks like you. If I get enough of you in there, I can expect the average is going to be 10. Okay, but I can also say the probability is 10%. So there's a 10% chance you're going to buy 100. 10% of 100 is also 10. So I'm just saying that this is just trying to figure out how much you're going to buy, so I know what I can, if I know that you're going to walk in the door, what is the expected value? The 1% chance of 1,000 or 5% chance of 30, whatever it is, I'm just going to multiply these probabilities and the amount together. So that's all I'm doing. And then here's the last one that I'm doing, which is a zero inflated. So first of all, people who didn't understand this, do you understand how I did it now? And please say no if you don't get it. Let's see. So Justin Floyd's asking, so since John does not have an automated, okay, well, would it be possible to post your notes on Poisson regression in the 490? Yeah, Tricia, I'd be happy to do that. I'd be delighted to do that. I'll post all this stuff if you want. Okay, now I got to post something else here. Poisson to 498. You guys are starting to make me work. Okay. Justin Floyd, 9.4 has it, question mark or no? What does 9. Oh, okay. He was asking about the zero inflated negative binomial. I don't know that, Justin. You'll have to check that. Okay. Tom, do you understand what I was doing with the hurdle model here?
Yeah, definitely. And I think I figured out what my hang-up was over here. I guess I was getting confused because I ran the code to, calculate the predictions from my models and then compared them to the predicted output from, the proc gen mod and proc reg and all those things. And I was just getting a little thrown off by the differences.
Okay. Well, we'll take a look at that in a minute. I do a final comparison down here on that stuff, so I'll show you how that all works in a minute. But does this part, what I did here, does this make sense to you?
Yeah, I'm good.
Okay, fair enough. Is there anybody in the class that doesn't get it? Please speak up because I can't read your mind. And I haven't yelled at anybody in 3 years, so tonight's not the first night if you don't get it. Here we go. Justin, for expected damage in Unit 2, a hurdle model. Thomas, could you read that to me? I can't read. I just didn't get the whole thing read to me.
Just for the expected damage in Unit 2, a hurdle model would have been a good route.
Yes, because that's exactly what it was. It was a hurdle model. A hurdle model is not just Poisson. It's any model where you're doing a probability and an amount and multiplying it together. That's a hurdle.
So really, if you did both parts, you did a hurdle model.
Yes, you did. The only difference here is for Poisson. Once you're playing around with Poisson distribution, if you really want to be a purist, you should first subtract one, build your model, and then add one back. If you don't do it, my suspicion is your answer is going to be wrong like 8 decimal places in, so it probably doesn't matter. However, if I don't do it, there's going to be somebody in this class that's like, that's wrong, and I'm going to have to, deal with that. So it's better to have it right and confuse, well, I guess it's not, and confuse 99% of the students why I'm doing it. But that's why I do this. So a hurdle model is not magic. It's not strictly Poisson. It's any model in your lifetime where you decide you're going to break it into two things, a probability and a severity, or a probability and an amount that the person buys. Anytime you do those and you multiply them back, it's a hurdle. What's the probability he's going to do it? And then once he does it, how much is he going to do? And I better be politically correct. What's the probability that she will buy? And if she does, how much is she going to spend? So I'm using pronoun political correctness today. That's just a little joke here, folks. Okay, so let me see, because I got a memo about that a while ago. Okay, so not from Northwestern, from someplace else. Okay, let's do the last one here, which is the zip model. Okay, so what am I doing there? If you're going to do a zip model, this is how you do it. Proc gen mod data equals blah, blah, blah. And then what you're going to do is SAS says use the whole amount, and then you're going to come up with a model which is the probability that the guy doesn't buy anything. So you're going to, you ram both of the guys. So instead of doing it a logistic model and a gen mod for the amount, you're shoving them both into one gen mod. Now, I don't like this. And the reason why I don't like this is because I have absolutely no control over it. What I love about breaking it into two different models is my proc logistic here. I can use stepwise selection and forward and backwards. And hey, I could use a decision tree. There's nothing magic about a logistic model. I could use a decision tree for my probability. I could use a decision tree for this guy. I could use a neural network for this guy or this guy. I can break this guy up into any different thing I want. I love the flexibility of this. However, I want to show you this because you're going to end up working someday and somebody's going to show you this and you're going to go, gosh, Don never showed me this. This must be, so this guy showing me zero inflated models must be a genius because I don't know what that is. No, I think it's too clever by half, but I want to show it to you. So here it is. So here's my model of a zero inflated Poisson. And by the way, you also say here's my zero model right there. And
so Don, I think this is what I was getting at when you were doing the hurdle model, and I just wanted to be clear, and sorry if I'm belaboring the point.
No.
But when you're doing this zip model with proc gen mod, you are doing the probability of zero of not
Yes.
buying anything here. Okay,
yes.
That's really what my question was. Okay.
Right. So we're
Sorry to
just
belabor it.
Nope, you're not belaboring anything. So here we go. We got the zero model. So this guy up here is a hurdle model, but we're breaking it into pieces, and I think it makes it more easy to understand, more elegant, more simple. If you're going to do it the hard way, let's do it that. And voila, there it is. Now, we have two things. We got a model for the amount of the wine the guy buys, and over here, did he buy zero? Okay, so let's see how that one works. I come down here, and first, the probability that the guy is zero. So here is the model. Then I cap it off at 1,000, and then I am creating it into a probability. So this is the probability of a zero. Then I take the gen mod, so I take this guy right here, which is the second guy. So this is the amount of damage that I have. And we do this guy here. and I do the exponent. And then take a look at this, Thomas. I'm saying this guy times 1 minus, because this is the probability of 0. So let's 1 minus the probability of 0 is the probability of 1. Does that make sense to you?
Yes, it does.
Okay. Are you sure this is clear to you? I'll post this. I'm going to post this code, but I want you to understand it.
Yeah, I'm in good shape.
Okay, fair enough. And just for fun, everybody, let's just show. I want to show you what I have, what I've been saying all along about this stuff being really robust. Okay, I have built about 5 or 6 different models here. And in fact, one of the models that I built is an ensemble model, which I'm going to talk about later after show and tell, which is I'm simply going to average the regression, the GenMod, negative binomial, my 2 hurdle models, and my zip model. I'm going to add them all up and divide by 5. And that's an ensemble guy. Now, just for fun, let me print these guys out. And you can see that my real answer for the first guy was 3 cases of wine. My regression predicted 4. My GenMod predicted 4. This guy predicted 4. They all predicted 4. And then I rounded everybody to the nearest case of wine. This guy was 3, 4, 3, 3, 3. So the regression missed it a little bit. The other guys got it. 5, 4. You know, take a look at this stuff. They're not that far off. And then when I finally predict all of the errors, you can see that the regression had, on the average, the regression was off by 1 case of wine, 1.03 cases of wine. My negative binomial was off by one case and some fraction. My hurdle model was 99%, off by 0.99% of a case. My other guy was 99, 98, and my ensemble was my closest guy, and he was off by, so in other words, averaging these guys. Remember I sent you guys all those links to the wisdom of the crowd? That's what an ensemble is doing, is just taking everybody and averaging it out. So anyways, he's my best answer, but he's not really that much better than my regression. So if you took a look at this, if you had come back to me and said, hey, Don, guess what? I'm violating every assumption in the book with linear regression. But you know what? It's simple. It's easy to understand. It's easy to implement. Everybody gets it. And you know what? I'm off by 0.05 cases of wine. You know what? I can't argue with that. I would go with this guy here. What I'm just simply telling you, if you're going to be an analytic street brawler, this is the way you go. I mean, sure, you know, if you were watching a kung fu movie with Bruce Lee or whatever, he's probably doing those kicks where he's flipping in the air and all that stuff. But you know what? In a analytic street brawl, you can pick up a brick and hit the guy. You're not going to win an Academy Award with that, but it's going to be effective. So that's what I'm simply saying, is go with something that works. You want to get you want something that's easy to understand and something that's easy to implement. And if the accuracy, you take a small hit on the accuracy and you don't lose any sleep over some assumption violations, this isn't a bad way to go. But you can see that this is how they all ended up in their accuracy. So anyways, Thomas, does it look like anybody has any questions or comments or thoughts or?
No, nothing in the chat window.
Okay. And let me see, I'm going to hop back up here. So I am officially, let me see, for the expected damage in Unit 2 hurdle, okay, that was Justin's. I'm done at this point. Does anybody, what about my 498 students? Do any of you guys have any questions about this material or your 498 final projects, because then my 411 students can hear questions or something. Maybe anything that you might ask might be something that they can. Okay, Trishul is going to ask a question. Trishul is from my 498 class. And what about anybody on the phone who's in my 498 class? Do we get graded on creativity for the presentation? I don't want to say get graded for your creativity, but I do want to say this. Tricia, I posted some of the presentations from previous classes. Did you get a chance to watch any of those? Yep, I saw some people did some nifty animation. Yeah, so here's the deal. If you're going to do a presentation, remember, I'm going to play the part of a CEO, and this is short attention span theater. If you start boring me with a lot of formulas and I start surfing the internet while you're talking, you know what? That's not a good thing for your career or your grade. You got to keep me engaged. I'm not going to say, wow, these guys were really creative. I'm going to give them bonus points. But if you keep me entertained, I'll understand it, and you're going to probably do better. Your job is to keep me entertained. Now, you don't want to be like getting too silly there. You want to, if you want to get creative, some people were very creative, and it's kind of, and you can have some humor. But again, remember, the CEO of a company doesn't want silly because he's giving you millions of dollars, and it might make them a little bit uncomfortable about giving you $1 million if you're getting too goofy. But at the same time, if it's too dry and it's boring, that's also bad as well. So you got to strike a happy medium, and keeping things simple and creative and keeping the audience engaged is a very good thing to do. So did that answer your question at all, Trishul, or not? Okay, I guess it did. Other questions out there? Angela Patterson, I'm going to draft you. You got a question for me?
Nope, I don't.
Okay, James Herbeck, what about you?
No, I was asking all your hurdle and zip models, so I'm good. Thank you, Don.
What about you, Yang Zhang? What about you? He's on mute.
Oh, yeah, sorry, Professor. Yeah, I'm good.
You can call me Don, but okay. Oh, well, okay, I'm going to stop recording here, and we're going to do we'll do some show and tell if whoever wants to do that. Okay, so last chance to ask questions.
I'll throw one out there, Don.
Okay.
I'm looking at just as a sanity check. My best model for the wine project is the zero inflated Poisson.
Okay.
And so I did a quick proc univariate on my predicted values just to make sure I wasn't getting anything crazy. I wanted to make sure I wasn't getting anything negative or anything too large. And I generated a histogram, and it doesn't look like a Poisson distribution. It looks weird.
Okay. How about if I share my screen and let's look at my distribution.
Okay.
Okay. So let's see. As you were typing, I'm going to do a proc univariate. Data equals score file, and do this real quick. I'm trying to remember the syntax. There it is. Histogram. There it is. So var. Which one you want? I'll do my zip model. How about that? And we want to do what?
Just histogram and run.
Okay, let's do that. Okay, so that was mine. It looked pretty good, but did you get this, or what did you get? Something that's totally different, or what?
Yeah, I got something pretty different.
Let's do something different. Let me run a proc regression instead. Yeah. See there, that's probably more what you got, right?
That is correct.
Okay. This does not necessarily mean you're wrong. What your goal here is to make good predictions on how many bottles of wine the person is going to buy. So you aren't worried about the final distribution. You're worried about your accuracy here. And if you're predicting 3 and the answer is 4 or something like this, so just because it's not looking like a real pretty Poisson model, I don't think you ought to lose any sleep over that. I could kind of see a little bit of a Poisson in here, but let's look at the errors instead. How about that? Let's look at the error messages or the error distributions. So here's my error for my regression. That's probably a better thing to do. I'm calculating my errors for my data set. Let's see what I got. So here's what I got for my my regression. A big 30% of my data is 0. I got them right on the money. I've got another big chunk of people, almost half of the data is off by 1 case, 20% by 2, 3, 4, and nothing beyond that. So, you know, if you're dealing with cases of wine, being off by 1, that's not too bad. Let's take a look at my let me see my zip model. Let's do that guy. See, this is how I would probably do it. If you're really worried about the distribution, don't look at the distribution of your predictions. Look at your distribution of your errors. Let's see about this guy. I don't see this guy's appreciably different. Maybe slightly more people are off by 2 cases, you know, slightly less. So this guy's probably, but he was more accurate. But, you know, still 30%, close to 50%, 1 and 2. You didn't have as many people off by 2 cases. So maybe your zip model was slightly more accurate because had more guys up here you know, more people were within 0 or 1 than the regression, but I don't see it as that much of a difference. What else could we do? Let's do the hurdle model. Let's see that, one of our hurdle models. Thomas, is this helping you out, or is this, or was that not your question?
No, this is helpful. I mean, I wasn't too worried about it because, you know, my mean absolute error is pretty decent, so I wasn't going to go too crazy over it. I was just kind of curious about it.
Yeah. You know, well, here's my hurdle model. That one actually looks pretty good, but I like it when it's a hurdle model, but more importantly to me, I would just like to look at the error distribution. That's the only thing that I would care about. If I was running a wine store and you told me your prediction, look, my prediction has got a nice pretty Poisson with a 0 inflation in there, I'm like, okay, that's wonderful. Now, how accurate is it? And then, you know, that's the only thing the guy's going to care about at the end of the day. He's going to say, if you tell me to buy 10 cases of wine, is that going to be 9 cases too many? And if I can tell you, look, if I tell you 5 cases, it's going to be plus or minus 1, and you can make a decision as, are you worried about getting stuck with an extra case of wine, or would you rather have one few case of wine if I'm off by that? You know, you decide if it's better to have too much or too little, and let the guy make a decision. But you know, that's something that will be useful for the wine owner. Would be looking at the distribution of the errors. So you could do that, and let's do our I don't know, gen mod, or let's look at the ensemble. I'm just curious about him. So 30%, 50. So he did pretty good too. So again, all these guys seem to be within one case of wine. You have 80% of your wine, your predictions are within plus or minus one case. That's not too bad. So that's how I would judge this thing. So am I helping you at all, or do you want to?
No, this is great.
Okay. So let's call this a night unless there's any final questions. Okay, we'll do show and tell now. Let me stop the recording.